Hello, everyone. This is Dr. Kenneth Ta. Today, we are going to consider Chapter 10. In this chapter, we'll talk about the basics of capital budgeting, So capital budgeting is going to be the heart of this chapter. Some topics we are going to cover will include an overview and vocabulary. Then we'll look at the different methods that are associated with capital budgeting that include MPV, which is net present value. We'll look at internal rate of return. We'll look at modified internal rate of return. We'll talk about profitability index. We'll look at the payback method, and we'll talk about the discounted method. So first, we are going to talk about present value. So the big picture is really how we value different projects. So net present value of a project. For most companies, they need to make a decision on which project they should invest in. It is really based on how profitable those projects are going to look like. So given several projects, they want to select the best. One of the methods is net present value, which is popularly being used. As we can see on this slide, net present value, the computation is basically using free cash flow. We take free cash flow and we compute the present value of each cash flow. We sum them up, and then we subtract the initial investment. So once we do that, that is going to give us the net present value. So we'll come back to this, and we are going to talk about the net present value, which is one of the techniques that is widely used in capital budgeting. Of course, the arrow that is being used in calculating the present value of each cash flow is the project risk adjusted cost of capital. So what is capital budgeting? Capital budgeting is analysis of potential projects. So again, there are different alternative projects. So it's making a decision on which project the company should invest in. So normally it's the project that is going to be profitable. This really long-term decision for most companies. So every time we hear capital in finance, it suggests long-term. So it tells us that the cash flow that is coming out from this kind of project goes beyond one accounting period, goes beyond 1 year. So it is long-term. So these are long-term decisions, and they usually involve large expenditures. So there is an initial cash flow, which is the expenditure that goes into this kind of project. And then there will be a series of cash flow that will start coming in. So this kind of decision that is long-term in nature and involve large capital expenditure is really what we call capital budgeting. And it's very important for the company's future, extremely important, because most companies are faced with capital budgeting decision. They need to make a decision on which projects they can invest in. So some steps in capital budgeting: there need to be an estimation of cash flows. Cash flows will include cash inflows and cash outflows. So the initial investment that is being spent, and then the cash inflows, the money that is coming out from that project. If a business is considering an extension of a branch or an extension of a part of that business, then there is a cash outflow, which is an initial investment. And eventually there is cash inflow, which is cash that is coming out from that project. So we need to be able to have an understanding or be provided or estimate cash flow that again is both cash inflows and outflows. We need to assess the risk of the cash flow. There need to be a determination of the weighted average cost of capital for the project, which we've just seen for the case of MPV. We'll come back to it, that we need to calculate the present value of all those cash flows. So we use R, the interest rate, or the weighted average cost of capital in calculating the present value. Then we need to evaluate the cash flows. So capital budgeting project categories. So these are the different kinds of things that businesses will consider to invest in. Project categories, they include things like replacement to continue profitable operations, things like replacement to reduce costs, expansion of existing product or markets, expansion into new products or market, contraction, decision, safety, and/or environmental project measures and others. So this is just different project categories. So as we can see, it's either expansion or replacement, and the company needs to put down large capital, and then they expect that that project is going to generate inflows. All right, as we get to start calculating using different methods in evaluating alternative projects, it is important for us to know whether the projects are independent or they are mutually exclusive. So if a project is independent, we mean that the cash flow of one are unaffected by the acceptance of others. So they are independent. The cash flow of one are unaffected by the acceptance of others, which means we can take the same project, because if we think of the case where we have two projects and we are thinking which one to invest in, if those two projects are independent and both of them are profitable, then a company might consider to invest in both projects. But there are projects that are mutually exclusive. If they are mutually exclusive, it implies that the cash flow of one can be adversely impacted by the acceptance of others. So for mutually exclusive projects, it's possible that when we accept one, then we cannot do the other. We cannot do the other because the cash flow of one is affected or impacted by the acceptance of the other. So in that case, if both projects are profitable, then we might not be able to accept both projects. We will need to take the project that is more profitable because they are mutually exclusive. All right, so this is an example of cash flow from two franchises, L and S. So if we look at this outlay, this is really a perfect representation of two projects that we can be interested in evaluating which project we should invest in. So in other words, this is really a layout for capital budgeting. So if we have two projects, we want to understand their cash flows. So we have cash flow for project L, L's cash flow, and we have cash flow for project S, S cash flow. So this is period 0. Then we have 1, 2, 3. We can see that's year 1, year 2, year 3. And then at year 0, we find a cash flow of 100. So there could be 100,000. So what that means, we see is negative for both project L and project S. So this is the initial investment. So this negative 100 is really the initial investment. So it's the money that is going out. So it's a cash outflow. And then we have the cash inflows. We have the cash inflows. So if we were to select project L, then year 1, we are going to receive 10,000. year 2, 60,000, year 3, 80,000. If we are to select project S, we are going to spend 100,000 right now. At the end of year 1, 70 will be received. At the end of year 2, 50,000 will be received. At the end of year 3, 20,000 will be received. So the question is, between project L and project S, which of them should we select? Which of them should we select? That is, this is a classic capital budgeting. This is a classic capital budgeting problem. We can either select project L or project S. So we are going to use a series of methods in order to decide whether we should select project L or project S. And the first method that we want to look at is what we call MPV, which is the net present value technique, the net present value technique or method. So companies widely use the MPV in making decision, capital budgeting decision. So the MPV basically calculate the present value of all cash flows, sum them up and subtract the initial investment. So if the formula of NPV is something like this, net present value is equivalent to sum of. So we take each cash flow, we calculate the present value, 1 plus I raised to the power n, and then we subtract the initial investment. So I'm going to put 0 here, and this is raised to the power n here. So this is cash flow n. So if we look at this, this is present value of cash flow, and this is initial investment. So that is the MPV technique. If we look at this carefully, if a company spends a certain amount, let's say 100,000 a year as the example, then that is the initial investment. We will want that the present value of all cash flows, which is something here, should be greater than 100. So if it is greater than 100, then the MPV is going to be positive. If the MPV is positive, then we can select that project. So decision criteria, MPV is greater than 0. What do? We accept the project. But if we have an MPV that is less than 0, we reject the project. So that is how we make decision based on MPV. So we calculate the MPV. If the MPV is greater than 0, if this is greater than 0, it means that the present value of all this cash flow is greater than the initial investment, which will make the project profitable. So we accept the project. If it is less than 0, then we are spending more money than money is actually coming in. So we reject the project. All right, so that is how we are going to work this problem. So let's look at the first example, which is franchise L. So as already discussed, this is the initial investment for franchise L. This is the first cash flow. This is the second cash flow. This is the third cash flow. It goes up to 3 years. This is the interest rate R. So here we have R, which is equivalent to 10%. So now we want to calculate the MPV. If we need to calculate the MPV, then we need to calculate the present value of all of this cash flow. We sum them up, we subtract this cash flow, which is the initial investment, if it is greater than 0, then that project is profitable. Franchise L is going to be profitable. So again, MPV is equivalent to MPV is equivalent to the present value of each cash flow, 1 plus R raised to the power n. We sum it, and then we minus the initial cash flow. So which means we have 10, 60, 80. So we take the present value. So present value of 10. So present value is future value, 1 plus R raised to the power n. So if we take this first one, which is 10, so we have 10, 1 plus 0.01 raised to the power 1. That is going to give us 9.09. Next one is 60, 1 plus 0.01. It comes in here 2 raised to the power 2. That is going to give us 49.59. The other one is 80 over 1 plus 0.01 raised to the power 3. That is going to give us 60.11. And then if we add all of that, so if we add all of this, we are going to take 9.09 plus 49.59 plus 60.11. So that is going to give us 118.79. Okay, so MPV is going to be 118.79 because that is the sum minus the initial cash flow, which is 100, and that is going to leave us with 18.79. So that is the MPV. So that's how we have MPV for project L. I'm doing this manually. So MPV for project L is going to give us 18.79. And I believe if we take our time and do MPV for project S, we will arrive at 19.98 and 19.98. All right, so if we look at this two projects, we need to make a decision whether we should select project L or whether we should select project S. And the decision criteria is that when MPV is greater than 0, we accept the project. So if both projects are independent, then we are going to accept both projects because they are all profitable. So this is profitable. Project L is profitable because the MPV is greater than 0. Project S is profitable because the MPV is greater than 0. But if both projects are mutually exclusive, then we might be in a position where we can only accept one. So in that case, we accept project S because the MPV is greater than the MPV of project L. All right, so that is how we walk through this problem using net present value technique. Net present value technique. So this just explains what we have done. MPV is the present value of cash inflow minus the cost or the cash outflow. Decision criteria: we accept a project if the MPV is greater than 0. If the projects are mutually exclusive, then we are going to accept a project with the higher MPV because that is going to add value. So as we have seen, if S and L are independent, then we accept both because their MPV is greater than 0. But if they are mutually exclusive, then we accept S because project S MPV is greater than the MPV of project L. All right. So we've seen the first method, which is MPV. We want to look at the second method, which is what we call the internal rate of return. How we use the internal rate of return to calculate, how we calculate the internal rate of return and make a decision on which project we should select. So this is a project, how a project look like, which we have already seen. So we have at time 0, the cost or the initial cash flow, which is actually the cash outflow. Then we have the cash inflow year 1, the cash inflow year 2, or the cash flow year 3. So all of those are the cash inflow. So we're interested in calculating the internal rate of return. We will define internal rate of return as the discount rate that forces MPV to be equivalent to 0. It's the discount rate that forces MPV to be equal to 0. So we can say it forces MPV to be equal to 0, or we can say the present value of all inflows is equivalent to the cost. So that is the same thing. So notice when we define net present value, we said it is sum of the present value of all cash flow 1 plus R raised to the power n minus initial cash flow or the costs, right? So sum. Okay, so now we say internal rate of return is the discount rate. So internal rate of return is the discount rate that forces MPV to be equal to 0. So if we equate this to 0, and then we make this arrow the subject, this arrow is what we call the internal rate of return. So it's the rate that forces MPV to be equivalent to 0, or we take this present value inflows to be equivalent to this cost. So if we send the cost the other way. So that is how we define internal rate of return. Again, is the discount rate that forces MPV to be equivalent to 0. So this is MPV. If we take the cash flow, and this starts from 0, or we start this from 1, and then we subtract the initial investment. When this MPV is equivalent to 0, this discount rate, as we've just said, is what we call the internal rate of return. All right, so our task now is to calculate the internal rate of return. This is for franchise L, and for franchise L, we have this cash outflow, then we have this cash inflow. So the outflow is 100,000, the inflow year 1 is 10,000, inflow year 2, 60,000, inflow year 3 is 80,000. So for us to calculate the internal rate of return, it's really tough to do it manually. It's tough to do it manually because we need to set up in such a way that we calculate the MPV, and then we look for the rate that MPV will be equivalent to 0. So for us to do this kind of problem manually is really through what we call a try and error method, where we are calculating the MPV. We are calculating the MPV, and as we know, MPV is cash flow n 1 plus R raised to the power n. So that is present value of all cash flow minus this cost or this initial investment. So we guess different rates, so we can start with any amount. We can use 5, we can use 5.1, 5.2, 5.3, 5.4, 6, and so on and so forth. So we are trying different rates and calculating the MPV until we get a rate for which the MPV is 0. Once we have a rate that gives us an MPV of 0, then we are going to conclude that that rate is the internal rate of return. That rate is the internal rate of return. So doing this manually is really difficult and challenging. So the best way to do this is either to use the financial calculator or to do it with Excel. So Excel is extremely easy. If we are doing it with Excel, all we need to do is to take equal. So if I'm doing this with Excel, so I just take equal internal rate of return, and I copy all the cells. So I copy all of this from the initial investment, and then I hit enter, and it's just going to generate. It's going to generate. It will generate the result. Okay, let me share it and see. Let me look for an Excel spreadsheet. So this is a spreadsheet share. Okay. So internal rate of return, of course, you also do MPV using the spreadsheet, but this is franchise L that we are interested in. Again, this is that initial cash flow. This is cash flow year 1, cash flow year 2, cash flow year 3. So if I want to do based on L, internal rate of return, I'm basically just taking internal rate of return and I'm dragging all the cells in. So if I'm somewhere here, all I need to do is to take equal, and I say internal rate of return, bracket open, so it needs the value. So I come here and I start from this initial cash flow and I drag it, and that is all. I take bracket close, and then I take enter, and it gives me the answer. So I need to format this cell to be able to see what I have there. So I take format cell, and I need numbers, 2, 4 decimal places. I take OK. If I times this by 100, that gives me 18.13%. 18.13%. So that is how we will calculate internal rate of return using Excel. So you basically just take equal, you take equal internal rate of return, and you drag everything, and it gives you the answer easily. Okay. Go back to my notes. All right, so seeing how we do internal rate of return using Excel, we just take equal internal rate of return, drag everything, and for L, we have 18%. If we do the same for S, we are going to get 23.56, 23.56. All right, so internal rate of return is the rate of return that is coming out from a project. It's the rate of return that is coming out from a project, which means that we need to compare internal rate of return with the cost of capital. to be able to make investment decisions or capital budgeting decision. Let me discuss that on the next slide. How is the internal rate of return on a project related to the yield of maturity? Internal rate of return, which we just discussed, is the discount rate that forces the present value of a project expected future cash flow to be equal to the initial investment, true, or that forces the MPV to be equivalent to 0. The yield to maturity is the discount rate that forces the present value of a bond cash flow to be equal to the price of the bond. So if we remember how we calculate bond price, we said it is the present value of an annuity plus present value of the lump sum, of a lump sum. So the rate we use in calculating this present value is yield to maturity. But for internal rate of return, is MPV equivalent to 0. The yield that we use, or the rate that we use, is the internal rate of return. Okay. So I'll come back to the rationale of internal rate of return. We have seen that the way we calculate internal rate of return is basically to use Excel, and we take equal internal rate of return, and then we drag in the cells, enter, that will give us the answer. We can also use a function in Excel that is called rate. That is if and only if we see this amount are the same. So in that case, if we are using rate, this 3-year represents that we have 40, 40, 40, they are the same, coming in 3 times. And then we take the 40 and we take this initial investment, which is 100, and that is going to give us an internal rate of return of 9.7. So that is using the function rate. So we can either use the function internal rate of return, or we use the function equal rate in Excel. But this one makes it really easy. Internal rate of return function in Excel makes it really easy. All right, now we can discuss the rationale for internal rate of return method. So if we think of a project, we want the project to generate a return that is greater than the cost of capital. So we always compare the internal rate of return with the cost of capital. If the cost of capital is 10%, for example, so cost of capital based on this arrow, or what we call the weighted average cost of capital, is equivalent to 10%. That's the amount or the rate that it costs the company to get money. If this company is investing that money in a project, we will want that project to generate a return that is greater than the cost of capital. So we can think of it in this way. If I go to the bank and I'm in need of money, and I borrow money from the bank, and the bank asks me to pay 10%, that would be the cost of me getting money from the bank. If I take that money and I need to invest it in a company or a project, if that project is going to pay me 8%, then I'm not going to invest in that project because I'll make a loss. My cost of capital is 10%. So I only invest in project that gives me a rate of return that is greater than the cost of capital. So that is investment decision using internal rate of return. That is the decision criteria. So the decision criteria is that once we compute internal rate of return, we need to compare it with the WACC, weighted average cost of capital. If internal rate of return is greater than the weighted average cost of capital, we accept the project. If internal rate of return is less than the cost of capital, then that project is not going to be profitable. We are going to reject the project. So that will be the decision criteria. So for the example we just looked at, we had an internal rate of return that was equivalent to 15%. And if we are given the WACC, the cost of capital, to be equivalent to 10, then 15 is greater than 10. Internal rate of return is greater than the weighted average cost of capital. So we are going to accept that project. We'll accept the project. So that is how we calculate internal rate of return, and then we make investment decision. We come back to the idea of projects that are independent or mutually exclusive. If two projects are independent and both of them are profitable, by both of them being profitable, we mean that the internal rate of return of project S is greater than the cost of capital. Internal rate of return for project L is greater than the cost of capital. If they are independent, then we accept both projects. If they are mutually exclusive, we accept the project that gives the highest internal rate of return. So if S gives a rate of return that is greater than the internal rate of return of L, then we are going to select S. We are unable to select both because the cash flow of one affects the other. The acceptance of one affects the other's cash flow. If we're to accept one and we invest that initial 100,000, then we might not have enough money to invest in the other project. So in that case, they are mutually exclusive. Okay. All right. We can look at how MPV can change, and sometimes it can leave us in a place where it is challenging for us to make investment decision, capital budgeting decision. If we look at different rates, we can vary different rates and then we calculate MPV for the different projects. So what we find is that when the rate is 0, MPV is going to be 50 for project L, 40 for project S. And as we vary these rates, the interest rate, they tend to generate different MPV. So somewhere here, what we will find is that the NPV for project L is greater than the NPVs for project S. But below this line, we find that the MPV for project L is less. All right, so I can just take the reverse and say the MPV for project S is what is greater than the MPV for project L. But we already established that the internal rate of return for S is greater than the internal rate of return for L. So internal rate of return for S is greater than internal rate of return for L. And internal rate of return for S is greater than internal rate of return for L. So this kind of thing can make it challenging for us to decide on a project. So here we will want to select, so here above this, based on internal rate of return, we want to select project S. But based on MPV, we want to select project L. So that's confusing. But if we look below, based on internal rate of return, so below, so it is somewhere here. Based on internal rate of return, we want to select project S, and then based on MPV, we want to select project S. So here it's easy. We can easily see that we are going to select S, and then here is confusing. So what we find is that there is a certain cross rate here, but we notice that WACC was given to be 10%, WACC or the cost of capital. So this is WACC, weighted average cost of capital is 10%. WACC is 10%. So we are interested in the numbers that we have below that cross rate, because WACC is below this line. And in this area, we find consistency. So in that case, we are going to select project S. Okay, so we can demonstrate this further. I have different MPVs that we can plot these MPVs on the y-axis, and these are different discount rate that we can plot on the x-axis. And if we plot based on this figure, then we will come out with a certain cross point here. And this cross point is 8.7%. So notice that this is really that 8.7%. So this is the cross point, 8.7%. And these are the respective internal rate of return that we computed. So this is the cost of capital here. So the cost of capital, so weighted average cost of capital. So below this cross point, we have S that is superior. So S is superior to L. So we are going to select project S. We'll select project S. Again, past the cross rate, we'll find the WACC, which is 10, in the area for which we have the WACC that we use in internal rate of return. S is above L. So making it possible, suggesting to us that project S will be superior to project L. Okay. So, and that is the area for which there is no conflict. There is no conflict in terms of MPV, and there's no conflict in terms of internal rate of return. So when projects are mutually exclusive, then we can look for the cross rate. If we have a situation for which there is a possibility that MPV suggests one thing and internal rate of return is suggesting another thing. And this cross point is going to guide us into selecting the project based on the WACC, and then we see that line S is greater than L. When the projects are independent, there is no conflict. So if it is independent, there is no conflict. Okay. So this is emphasizing what we've just said. This is the cross rate. So above, there is no conflict because MPV is suggesting the same project, like internal rate of return, no conflict. But here MPV is suggesting L, internal rate of return is suggesting S, so there is a conflict. And that is where we have below this cross point. So this is the area for conflict, and the above is the area where there is no conflict. All right. So I can show us how we can calculate this cross point easily. We can do exactly like we calculate internal rate of return. but we must take the difference. We need to take the difference. So we have we have year. So we have year 0, year 1, year 2, year 3. And then we have S, initial cash flow is minus 100, 70, 50, and 20. Okay. Then we have L, initial cash flow is 100, 10, 60, and 80. So what we do is to calculate the difference. For us to calculate the difference, we take this 100 minus 100, that is going to be 0. We take 70 minus 10, this is going to be 60. We take 50 minus 60, this is minus 10. We take 20 minus 80, this is minus 60. And then we compute the internal rate of return. We compute the internal rate of return. So the internal rate of return of this difference is really what we call that cross rate. It will give us the crossover rate. So if we do that, that will give us 8.68%. 8.68%. So this is how we can calculate the crossover rate in Excel. So given the two projects, notice that taking our time to plot this on a graph suggests 8.7. But if we were to take the difference in the project and then calculate the internal rate of return, we get that 8.7. We get that 8.7. Okay, so we can see this in Excel. So we come somewhere here, look at. So if we take time to plot, we get the cross rate. But these are the two projects, and then we get those differences here, and then we calculate the internal rate of return, and we drag everything out. Okay. Let's see this out. So equal internal rate of return, bracket open, and I drag this cash flow differences, bracket close, enter, and this gives me the internal rate of return. I just need to format the cell, keep it to numbers, and take it to 4 decimal places, and times it by 100, that gives me 8.68%. Okay. All right, so that is internal rate of return. So we have seen how we make capital budgeting decision based on net present value technique, and then based on internal rate of return. And that sometimes we can have NP and internal rate of return that gives us contradictory evidence. So we can calculate the crossover rate, and then we make a decision based on the point for which we have the WACC. We can clearly see which project is superior to the other project. Okay. Another method that we want to see is a modification of internal rate of return. So we call that the modified internal rate of return. The modified internal rate of return. So modified internal rate of return is the discount rate that causes the present value of a project's terminal value to be equal the present value of the costs. So the terminal value is found by compounding inflows at the weighted average cost of capital. So thus, the modified internal rate of return assumes cash flows are reinvested at WACC. All right, so what this is telling us is that we calculated almost similar to the way we calculate internal rate of return, but we need to calculate the terminal value. So projects are generating cash flow period after period, but if we reinvest those cash flows at WACC, we are going to have a certain future value, one future value. And then the sum of that future value is what we call the terminal value. That is what we are going to use in calculating the internal rate of return. So when we do that, that is called the modified internal rate of return. The modified internal rate of return. All right, so if we come back to Project L, franchise L, the rate is given as 10%. Then we have this initial cash flow, 100,000, year 1 through year 3, 10,000, 60,000, 80,000. We can calculate modified internal rate of return in Excel, basically by hitting equal to modified internal rate of return, and that is going to give us the answer easily. Okay, so but when we take modified internal rate of return, it's going to ask us to get the cash flows, which in this case, we are going to drag all of this. Then it's going to ask for the rate, which in this case, we are going to take this. And then we take enter, and that is going to give us 16.50. 16.50. So I'll come back to the spreadsheet, but let's see how this can be done manually and the implication of that. So doing this manually, we assume that all these cash flows are reinvested, or doing this in a way that really explains what modified internal rate of return is all about. So these are the respective cash flow, negative 100, which is cash outflow, 10, 60, 80. Okay, so this is the interest rate. So we take this 10, once it comes, this is the cash flow, we reinvest it at the 10% rate. So it is going to give us 12.1 at the end of year 3. Okay, then we invest this 60,000 that comes year 2 at this rate, is going to give us 66,000 at the end of year 3. Then we have this 80,000 that comes at the end of year 3. So what we are basically doing is that we are calculating the future value, and we know that the future value is present value 1 plus interest rate raised to the power n. So this year 3 is coming, this 80,000 that comes year 3, the value is going to remain 80,000 because that's the value at the end of year 3, and 80,000 comes at the end of year 3. So it's like, what is the value of 80,000 if I give you 80,000 now? It's going to be 80,000. All right. Then this 60 that comes year 2, from year 2 to year 3 is 1 year. So if we're to calculate that, we'll take that 60,000 as present value, 1 plus the interest rate, which is plus 0.10 raised to the power 1, because it came year 2 and we are going to year 3. So once we do that, that is going to give us 66,000. Then we have 10,000, 0.10 is going to be to the power 2, because this 10,000 comes at year 1. We move to year 2, we move to year 3, so it is 2 years. We calculate the present value, that is going to give us 12.1. So if we take this 80 that came in at the end of year 3, add everything, we are going to have 158.1. Okay. So that is what we have. We have this 158.1, and then we have this 100. So we need now to calculate the internal rate of return. So in calculating the internal rate of return is the rate for which the MPV is going to be 0. So it is the MPV of this terminal value, the present value of this terminal value. So in other words, we are taking 158.1 raised to the power 1 plus modified internal rate of return raised to the power 3, that's the present value, minus 100, this should be equivalent to 0, because that is the definition of internal rate of return. And then we look for this, which we are going to give us, is going to give us 16.51. So this explains what is going on, how we get to this terminal value. So to get to this terminal value, we reinvest all these cash flows. If we reinvest all these cash flows, it's going to give us this terminal value at year 3, and then we calculate the MPV. So that gives us an understanding of how it is calculated. Again, we can basically use the financial calculator. If we're to use the financial calculator, Excel will be much easier. Let's see. We just use the function internal rate of return, modified internal rate of return. All right, so notice these are the cash flows. If we take modify internal rate of return, it is going to ask us for all the cash flows for the values. We take the values. It's going to ask us for the finance rate. That finance rate is this 10%. It will ask us for the reinvested rate. We are reinvesting at still the WACC, which is 10%. We take enter. That is going to give us the 16.5. The 16.5. Okay. 16.5. So let me do it somewhere else. So I come here, I take equal. I need modified internal rate of return. Okay. Modified internal rate of return bracket open is asking for the values. I take in the values. Then I take comma, it's asking for the finance rate, which is 10%. I take comma, it asks for the reinvested rate, which is that. And then I close the bracket and I hit enter, and that gives me the answer. For me to see clearly, again, I need to make sure that my cells have the right value. And then times 100, that is going to be 16.5. So that is how we calculate modified internal rate of return. Okay. All right, so we have seen how we calculate and make capital budgeting decision, how we decide between alternative projects using number 1, net present value technique, number 2, internal rate of return, number 3, modified internal rate of return. Modified internal rate of return greater than WACC, we accept that project. Modified rate of return for a project greater than the other modified rate of return, we select the project with the highest modified internal rate of return in case both projects are mutually exclusive. Okay. Now we want to go to the fourth method, which is what we call the profitability index. The profitability index is the present value of future cash flow divided by the initial investment. So it measures the bang for the buck. Initial investment is the buck. The bang is the present value of the future cash flow. So it's really similar things that we use in the calculation of present value. But now for profitability index, we basically take the present value of those cash flows. So if it was net present value, we subtract initial investment. Here we basically divide initial investment. So this is the bank, this is for the buck. So it is the present value of cash flow divided by the initial costs. So that is how we calculate profitability index. Okay. And the project that gives us the highest profitability index is the project that we are going to select. All right, so this is straightforward for project L. If we have calculated, we had calculated the cash flow of this investment before, we basically take that and we divide it by the initial investment. So profitability index is the present value, some present value of cash flow divided by that. So we have 10, 60, 80. So the present value is future value 1 plus r raised to the power n. So for us to calculate for 10, that is going to be here 10 over 1 plus 0.1 raised to the power 1. That is going to be 9.09. This is going to be 61 plus 0.1 raised to the power 2. This is 49.59. And then here we have 80. 1 plus 0.1 raised to the power 3. That is going to give us 60.11. We sum it up, which will give us 118.79. So profitability index is 118.79 divided by 100. If we do that, and this is profitability index for project L. For project L, this is going to give us 1.1879. Okay. So 1.1879. If we take our time and do it for project S, we are going to have 1.19. So notice project S is going to be higher than project L. So we are going to select project S if both projects are mutually exclusive. So that is how we use profitability index. Okay, let's look for another method, which is the payback method. Payback method is not widely used, but could be very informative, can give us a lot of information. Payback period is basically the number of years required to recover the project's costs, the length of time it takes to recover the project's costs, payback. So the shorter the time, the better. You know, we always want to get our money quicker. So if we have invested 100,000 in a project, and there are two projects, one takes 2 years to recover 100,000, the other one takes 50 years, we will want to select the project with the shortest payback. So that's the whole idea behind the payback method. So we can use payback for franchise L. These are the respective cash flows that we have seen. We want to understand the payback, which is the length of time it takes us to recover our initial investment. So all we do is to calculate the cumulative. So we start from here, the cumulative of 100 so far is 100. Then the cumulative here after 10 comes in. So we have negative 100 plus 10 that comes in. This is negative 90. So this gives us negative 90. Then we have negative 90. And then we have 60 that comes in. So we have negative 90 plus 60 that comes in. When 60 comes in, this gives us negative 30. Okay, we have negative 30. Then we have 80 that comes in. When 80 comes in, we have negative 30 plus 80. So this gives us 50. So these are the cumulative amount. The cumulative amount we start here, which is 1, negative 100, negative 90, negative 30, 50. So by the time we 50, we see that somewhere here we have we've broken even. Okay, so we're able to recover our 100,000. This is negative, this is positive. So, and this is between 2 and 3. Between year 2 and year 3, we get back our initial investment. So it is 2 point something. How do we get the point something? We basically say our payback is going to be 2. And then notice this. This is going to be 30 divided by 80. So payback comes in 2 and a certain fraction. That fraction is going to be plus. When we look at this, we take $30 divided by $80. That gives 2.375 years. So that is the length of time it takes us to recover our initial investment for project L. We can do the same for project S. And what we will find for project S is that we get our money back between year 1 and year 2 because the cum year is 0. So it is going to be payback will be year 1, and then plus we take 30 divided by 50. So plus 30 divided by 50, which will be 1.6 years. So based on project L and project S, we are going to select project S based on the payback method because we recover our initial investment faster. So we'll select project S. We get our initial investment in 1.6 years for project S, but for project L, we get it back in 2.375 years. So project L is going to be the project S, franchise S is going to be the project we are going to select because it takes a shorter time for us to get back our initial investment. So the payback method has certain strength. They provide an indication of project's risk and liquidity. The shorter we get our money back, the better, which means that that project is more liquid. We can easily get back our cash. And it also tells us a certain element of risk. The longer the payback, the more risky the project is. Imagine 2 friends came to you in need of money. One say, I'm going to pay you back next week. The other one say, I'm going to pay you in 20 years. You will not want to lend your money to the person that will pay back in 20 years because there is so much risk that is involved. You are not sure where the person will be in 20 years' time. So payback method provides an indication of project risk. The longer the time it takes to get your money, the more the risk. Another strength or advantage of payback is that it is easy to calculate and to understand. But payback also has certain weaknesses. Number 1, it ignores time value of money. When we are calculating payback, we are adding these cash flows we are adding them as if 50,000 that is going to come in year 2 is the same as 50,000 today. We are adding as if 20,000 that will come in year 3 is equivalent to 20,000 today. So when we do that, we ignore the time value of money. Another weakness is that we ignore the cash flow that is occurring after the payback period. So when we look at these two projects, if we were to change something, so let's say we were even to increase the number of years in this project, and somewhere here there is 20 million that is coming in, and then this is year 4, somewhere here there is let's say 13,000 that is coming in. We are still going to select project S because it takes a shorter time to get back the initial investment of 100. So any cash flow that is coming after the payback period is ignored. So there is a 20 million that is coming here in year 4 that could be very profitable, but we will still reject this franchise L. So that is a weakness. So the weakness is, number 1, ignores time value of money. Number 2, it ignores cash flow occurring after the payback period. And then number 3, no specification on acceptable payback. So even though in general we want a shorter payback, there are some companies that would prefer payback in 5 years, others would prefer payback in 3 years, others would prefer payback in 10 years. So there is no specification of accepted payback. Okay. So the last method we want to look at is what we call discounted payback. Discounted payback basically tries to improve the measure limitation of the payback period. The payback period main limitation, main weakness is that it doesn't take into consideration the time value of money. So discounted payback steps in and consider the time value of money. So these are the respective cash flows. So considering the time value of money, excuse me, basically imply that we calculate the present value of all those cash flows. We calculate the present value of all the cash flows. So the present value of negative 100 that leaves right now remains negative 100. This 10 that comes at the end of year 1 is not equivalent as $10 or $10,000 right now. So we are calculating the present value. So we know that present value is equivalent to future value, 1 plus r raised to the power t. And that is how we have this 9.09. So the future value here is 10, 1 plus r, the interest rate is given, the discount rate is given as 10, I believe. We had used it before. So this is plus 0.10 and raised to the power 1. So that is going to give us 9.09. And then here we have 61.1 raised to the power 2. That is going to give us 49.59. And lastly, here, this is 81.1 raised to the power 3, which is going to give us 60.11. So we've calculated all the present value, and then now we look for the payback. So the same thing, but we are using discounted cash flows. We are using the present value. So we have this 100 that came in year 1. We are adding them up. Now we have plus 9.09. So we are at negative 9.91. We are taking the cumulative. By the time we get to 0, or we just go past 0, it means we have recovered our initial investment. Then we take this 90.19 and we add this amount that comes in, the 49.59, that gives us negative 41.34. It's gradually dropping. Then we add this 60.1, that now gives us a positive number, which means that we start making profit. We have recovered our initial investment. So in terms of years, the payback is actually between 2 and 3, but precisely what fraction? It will be 2 plus the fraction we are going to take. We use these two numbers here, which will be 41.32 divided by 60.11 to get the fraction. So if we do that, the discounted payback is going to be 2.7 years. So that is how we use discounted payback. And the project with the shortest discounted payback, is the project that we are going to select. So those are the different methods in selecting alternative projects, which is the heart of this chapter, capital budgeting. We have seen how we can select project using the net present value technique, how we can select using the internal rate of return, how we can select among alternative projects using the modified internal rate of return. We've seen how we use the profitability index, how we use the payback method, and how we use the discounted payback method. So that is it for this chapter. Thank you.